Alright, so it's time to talk about the Karnaugh map. So what's Karnaugh map? What is it good for? Well, generally, whenever you represent, entries for your truth table and so on, you generally use, the truth table form. So for instance, if we have something like A, B, C, D, and then the output, we can say, okay, we can use the truth table and say all the possible combinations. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0. And let's suppose that our output in this case is 0, 0, 0, 0. And then we can go on and do all the other combinations. So 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0. And I can say that in this case the combination is 0, 1, 1, 0 of the output. And then we can go on and say, okay, we also have 1, 1, 0, 0. The output, I don't know, 0. And then we have 1, 1, 0, 1, 1, 1, 1, 1, and 1, 1, 1, 0. So we have 1, 1, and 0. And then we have 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, and 1, 0, 1, 0, and 0, 0, 0, 0. And also 0, 1, 0, 1, and 0, 1, 1, 1, 1, 1, 0, 1, and 1, 1, 1, 1, with the output 1, 1, 1, 1. So as you can see, whenever you have, even 4 variables and so on, it kind of gets messy, like really messy, because you have, well, if you had 3 variables, then it was kind of fine, but with 4 variables, then it's kind of long to write down a truth table. So what do we do? Well, to avoid this, we can actually make a Karnaugh map. So a Karnaugh map actually looks like this. We have, if we say that this is 0, 0, 0, 1, 1, 1, 1, 0, and here we have 0, the same thing, so 0, 0, 0, 1, whoops, 0, 1, 1, 1, 1, 0, and say that in this case we have AB, and here we have CD, and we can build our map according to this. So when A and B is 0 and C and D are 0, then the output is 0. When A and B are 0 and 1, no, sorry, when A and B are 0 and when C and D are 0, 1, then the output is 0. When A and B are 0, C and D are 1, the output is 0. When A and B are 0, C and D are 1 and 0, then the output is again 0. And then we go on. When A and B is 0, 1, and C and D are 0, 0, then the output is 0. When A and B are 0, 1, C and D are 0, 1, then the output is 1. When A and B are 0, 1, C and D are 1, 1, then the output is 1. When A and B are 0, 1, C and D are 1, 0, then the output is 0. And then we go on. When A and B are 1, 1, C and D are 0, 0, then the output is 0. When A and B are 1, 1, C and D are 0, 1, the output is 1. When A and B are 1, 1, C and D are 1, 1, the output is 1. When A and B are 1, 1, C and D are 1, 0, the output is 0. When A and B are 1, 0, C and D are 0, 0, then the output is 0. When A and B are 1, 0, C and D are 0, 1, then the output is 0. When A and B are 1, 0, C and D are 1, 1, then the output is 0. And when A and B are 1, 0, C and D are 1, 0, then the output is 0. So again, we notice that in this case, those here are the one we are actually interested in, which are like the only times in which is 1, okay? And this is also one of the reasons why I counted in this way. So if we just make these like so, like this, then we get our beautiful Karnaugh map. So this is a Karnaugh map for 4 inputs, and it basically tells you in a way more clean way how to basically get the desired output starting from the input. So this is how you make a Karnaugh map. How do you use a Karnaugh map? Well, in order to write down a function starting from this Karnaugh map, if for instance SSI gives you a Karnaugh map and wants you to write down the function, then what you do is that you start looking for where it's 1, and you basically have a technique that it's find the prime implicant. So what's a prime implicant? Well, a prime implicant is where a group of number in which all the numbers are 1, and you can only make a group that is a power of 2. So and you can move on, going up, going down, going right, and going left. And for instance, if you had a map with multiple things, like you could go from here and go back from here, or up and go back down and make a group with those. Ideally, you want to make a group which is as large as possible. So in this case, I'm just gonna make my group like this, with all those 1 here. The reason why I make this is that, sure, I could just make a group of 1 or a group of 2, like this and this, or these 2 and those 2, but there is no point in doing that, because those prime implicant such a group wouldn't be within the shortest, well, the largest possible group. So they're not going to give me, if they're not with the largest possible group, they're not going to give me the shortest possible expression, so they're not use. So yeah, this is my group of prime implicant. So now I'm going to have to look at when those A, B, C, and D are asserted. So when are those asserted? Well, I'm going to look at when A is asserted. What does it mean? Well, it means that I'm going to have to look when A is 1. So when is 1? Well, A is 1 here and is 1 here. So I'm going to put A here. Because A is 1 here and here. Then I'm going to do the same thing for B. B is 1 here and here. So I'm going to put here, down here, B. Then I'm going to do the same thing for C. C is 1 here and here. So I'm going to put here C. And D is 1 here and here. So I'm going to put D here. Now I'm going to do something. I'm going to have to write my expression. F of A, B, C, and D. So what's my expression? Well, my expression is actually given by where those are asserted. So I'm going to look at A, but this is only one group, so it's fairly easy. I'm going to look at A first. Well, this is my group. Is it completely inside A? No. It's half inside and half outside, because this part here doesn't fall inside A, so I'm not going to put anything for A. Then I'm going to look at B, and I'm going to see that the group is actually all inside B. So I'm going to write B. Then I'm going to look at C, and C covers these two areas, but those group of 1, part of this group is actually outside C, so I'm not going to put anything for C. And then I'm going to look at D, and D is actually, it covers everything, so it's all inside D. So I'm going to say, okay, B, D. And this is my expression for this all messy table. So as you can see, making a Karnaugh map is really, really useful, because it's going to allow you to write down an expression which is, way, way easier than looking at all those tables and this. So yeah, this is my expression. By the way, if I had something like, I don't know, if I had something more complex, in which, for instance, A it was completely outside, like, what if I had, well, no, let's just make another example, shall we? Let's make another example. So if I had something like this, 01, 11, 10, and then I have 00, 01, 11, 10, and I had something like 1, 1, something like this, and all 0 here. Yeah, just gonna put all 0 here, and I don't know, like 1, 1. Okay. Then in this case, I'm gonna have two groups. But I'm essentially going to do the same thing. Okay. So those are going to be AB, and those are CD. Okay, so in this case, I'm gonna choose this one as my group, and this one as my group, and I'm gonna do exactly the same thing. So A is asserted here, B is asserted here, C is asserted here, and D is asserted here. So let's look at the first group, shall we? The first group, 1, 1, falls completely outside A, because A covers this one, but is never inside this. So my f of a, b, b, c, d is actually not a, because it's completely outside. Then what about b? Also b is completely outside, because it only covers this area, and those two ones are completely outside, so not b. And then I'm gonna look at c, and also c is completely outside because it covers those two, so not c. And I'm gonna look at d. D is half inside and half outside, so I'm not gonna put it in here. And then I'm gonna have a plus. I'm gonna look at the other group. So this one, with those two one, are actually inside A, so I'm gonna have A. Those two one are half inside and half outside B, so I'm not gonna put anything for B. Those two one are completely inside C, so I'm gonna put C. And they're completely outside D, because D covers those two, and those two ones are completely outside, so I'm gonna put not D. And this is actually my expression for this other Karnaugh map. And there can be any kind of different Karnaugh maps, and they can be larger, way larger than this, and they're, I kind of like Karnaugh maps because, yeah, sure, a truth table is absolutely fine, gives you a sight of what's happening, but as your system gets larger and larger, writing a truth table is not, it gets messier and messier. So you don't really want to look at something like this if you have, I don't know, like not D, but I don't know, if you have 16 inputs, so 16 variables, you don't want to look at a truth table. You better want to look at the Karnaugh map and eventually make your own function, expression for the function. So yeah, this is pretty much it about Karnaugh maps. Eventually, you can make some other example about larger Karnaugh maps and how they help you greatly minimize the effort in writing that you have to make to write an expression. But anyway, so yeah, that's pretty much it for this video, though.